Hi guys, Amanda and Xavier here. We will be discussing the effectiveness of COVID-19 testing and in particular the RT-PCR test, which gives results the same day. The rapidness of this test raises questions about the accuracy of the test, which is why we wanted to evaluate the prevalence of both false positive and false negative results associated with this test specifically. Common symptoms of COVID include fever, sneezing, coughing, fatigue, difficulty breathing, headache and body aches, loss of taste and smell, sore throat and runny nose, and diarrhea and nausea. Diagnosing COVID-19 with the RT-PCR test uses a nasopharyngeal or oropharyngeal swab and testing for the presence of viral RNA in the sample. Reverse transcriptase polymerase chain reaction, RT-PCR, requires extraction of the RNA from the sample, which must then be converted into DNA. This is an important step as DNA can be amplified using the polymerase chain reaction, whereas RNA cannot, making it harder to quantify. RNA is converted into its complementary DNA using the enzyme reverse transcriptase. By the end of this step, a collection of complementary DNA strands will have been formed from all of the RNA present in the sample. This includes everything from bacteria to other viruses to the patient's own cells. In order to determine whether the SARS-CoV-2 cDNA is present and to identify which specific strand it is, PCR is used. The first step of the PCR process involves denaturation of all of the DNA, which simply means separating the double-stranded DNA into its individual strands. A pair of primers are then used, which are short nucleotide sequences specific to the SARS-CoV-2 DNA sequence. These primers attach to the complementary sequence of cDNA only if it is present. Finally, the enzyme DNA polymerase is used in the elongation step to add nucleotides to the ends of the primers using the original strand as a template. This effectively multiplies the double-stranded molecule as a three-step process is repeated, doubling the number of double-stranded DNA molecules each time. Real-time RT-PCR employs a probe during the PCR process, which gives off a fluorescent signal every time a DNA molecule is formed. This means that the formation of viral cDNA molecules can be tracked in real time by observing the increase in fluorescent signal. Formation of viral cDNA molecules can be tracked in real time by observing the increase in fluorescent signal. When this signal surpasses a predetermined threshold, it can be said with confidence that the signal exceeds the background level. A cycle threshold, or CT, is related to the threshold, which is associated with the number of cycles the RNA must go through for the fluorescent signal to overcome.